All right, today we're in lesson 1 of our new unit called Polynomials. And today we're going to be adding and subtracting polynomials within expressions. Adding and subtracting. So no multiplication and division today, just addition and subtraction. All right, now this part is not necessarily in your notes, okay? I just kind of want to give you a breakdown about polynomials, and then we'll get into your fill in the blanks, okay? So the first little fact about polynomials is what a term means, okay? So a term, you're going to hear me say that word today several times. It's the parts of an expression being added or subtracted together, all right? So that's just a term. Like terms have the same variable and they are raised to the same power. So you're going to hear me say that, okay? Yes, they both have an x, but do they both have the same exponent? They have to also have the same exponent to be a like term. Standard form. This is when the exponents of terms are in descending order from left to right. We always want our answers written in standard form. Okay? The leading coefficient. Coefficient. Does anybody remember what a coefficient is? Let me give you a term to look at. 3x. Can anybody tell me the coefficient in that term? What is the coefficient? The coefficient is the number only part of the term. So it's in a term with a variable, but it's only the number part. Okay? So the leading coefficient is when the polynomial is in standard form, it's the very first number, okay? And a coefficient in general is the number in front of the variable. It's not the variable, it's the number in front of the variable, all right? So what is degree? All right, we're about to talk about degree. Degree is the largest exponent or the sum of exponents in one term, okay? So if there's more than one variable, there could be more than one exponent in one term, so then I would add them together. We're going to see that in the next example, all right? So this is just, again, some of the terminology that we will need to know for polynomials, all right? So what is a polynomial? Well, it's a monomial, meaning one, or a sum of monomials put together. So that's what we see here. We see monomial, all being added together, which makes it a polynomial. So simply put, a monomial has one term. A binomial has two terms. A trinomial has three terms. I don't know what has four terms. A quadrinomial, it doesn't matter. Okay? All right, everybody got your blanks filled in? You guys have your terms filled in? And we are ready to go with our examples. 3 examples here in this lesson. You guys ready? Okay, all right, so here we go in example 1. In example 1, all we are doing is finding the degree of the monomial. The degree of the monomial. Okay, so that means the largest exponent value in one term. If there are multiple exponent values in one term, I would add them together. I'm only looking at the exponent value. I was told last hour that the 4 is big in your notes. So if you could just make that an exponent, go ahead and rewrite that term in your notes, negative 3x to the 4th power. Okay, so because we see a power of 4, the degree of that term is 4. The degree is 4. All right, now look at the next term. Do you see that there are 2 exponent values within that one term? So when that happens, the degree will now be 3 plus 2, which equals 5. I'm simply adding my exponent values together to find the degree of the term. What's my exponent value on my last number? What's my exponent value, guys? There's no exponent there. So what number would be understood to be my exponent? 1. So this is to the power of 1. So my degree is 1. That's it. Okay? So the degree of a term is the largest exponent value in the expression. All right, now let's talk about writing a polynomial in standard form. Now remember what I just said, your answer has to be in standard form. So let's say that these are all simplified expressions, meaning that there's nothing to simplify together. I simply have to write what's there, or the simplified expression, in standard form. That's all I'm doing. Standard form says I start at the highest exponent value, I work my way down, and my number comes last. Okay? So on my first term, or on my first expression, I need my variable to actually come first in the expression. So here's my question. When I bring it down and write it out front, will it be positive 9z or negative 9z? The sign in front of the term must follow the term. So does everybody see the subtraction sign in front of the 9? That also means that 9z is negative because you're taking it away. Okay? So the sign in front of the term must follow it. That's why it's negative 9z. All right? The same thing goes with 4. Because there is nothing in front of the 4, does that make it positive or negative? Positive. Positive. So I must write plus 4. And this is it. I've written it now in standard form. Descending order, starting with my variables. All right, so look at the next one. What is the highest exponent value that you see in that expression? The whole thing, though. Do you see t to the third power? Does everybody see that? That's the highest exponent value. So, is it big? Okay, so rewrite it to make them small. T to the second power minus t to the third power minus 10t. I got to watch that because apparently when I convert from PowerPoint to notes, sometimes the powers fall out of the exponent because it didn't happen on all of them. It just happened on those. It's so weird. Okay, so does everybody agree t to the third power is the largest exponent? Okay, so when you bring it down, would you bring down a positive t to the third power or a negative t? You would bring down negative t to the third power because of the subtraction sign in front of it. It is the same thing. Okay, that still makes t to the third negative. So for t squared, I need to bring down t squared next because, again, it has to be in descending order. Would it be plus t squared or minus t squared? T squared. Plus. What's in front of t squared, guys? Nothing, which means it's positive. Plus t squared. Try to make sure your pluses don't look like t's, okay? Otherwise, it can get confusing. Now, would I bring down plus 10t or minus 10t? Minus, because there's a subtraction sign in front of it. Okay, are you guys getting the hang of seeing the sign in front of the term? Okay, all right. Now I want you to do the third one on your own. I'm going to pause real quick and give you a minute just to do that one. All right, so how would I write it? X to the third power plus 2.8x. Okay. All right. We still have some work to do. Then classify by the number of terms. Okay. So what kind of polynomial do we have here? How many terms do we have? On the first one, 2. So this is a binomial. All right, what about the middle one? What is that one? What's this middle one? It's, how many terms do I see here? 3, so it is a trinomial. All right, what about my last one? How many terms? 2, so binomial. Okay, now the last thing, it says identify the degree and the leading coefficient. Okay, so the degree is the largest exponent value in my terms that have variables. So what is the degree in the first expression? Negative 9z plus 4. What's my degree? What exponent do you see? Nothing, which means it's an exponent of 1. So my degree is 1 on my first expression. What is my degree on the second expression? What's my degree on the second one? I'm looking for the largest exponent value in one of those 3 terms. What is the largest exponent value that I see in one of the 3 terms? 3. So the degree is 3. You do not add them together unless the exponents are together in one term. Okay? Does everybody see why 3 is my largest degree? Because it was my largest exponent in the expression. All right? So what would be the degree on my last expression? What would it be, guys? 3 again, because it is my largest exponent value. Okay? Now I'm going to call it LC for leading coefficient. That means when the expression is written in standard form, this is the very first coefficient that I see. Okay, remember what a coefficient is. It's the number part connected to the variable. All right, so let's look at the first one. The very first coefficient that I see is what number? Negative 9. So my leading coefficient is negative 9. What would be my leading coefficient on the second term? Hold on. It's the very first coefficient that I see. Wait a second, I don't see one. Because it's an understood what? 1. Every variable has a coefficient in front of it. If there's nothing there, it's a 1. So my leading coefficient on my second expression is negative 1. Does everybody see why it's negative 1? Because in the very first term, I always look at the first one. There was nothing there, but there was a negative. So I know that means negative 1. So what's my leading coefficient on the third expression? Positive 1. Okay? All right. Any questions? This will be on your homework tonight. Okay? Last example, we're going to simplify them now. Okay? So when it is addition between the 2 expressions, do you see the addition sign here? Do you see the addition sign? Then I am ready automatically. I don't have to do anything. I am ready to start combining like terms. Okay? So the first thing I'm going to do is I'm going to reorder these terms to put the like terms next to each other. All right? So we always start by just bringing down our highest exponent value within the whole expression. Does everybody agree that x squared is the highest exponent we see in this whole problem? Does everybody agree? Do you see any exponent that's higher than x squared? Do you? I'm going to write that first. X squared. Do you see any other terms in this expression, the whole thing, that also have an x squared exponent? Do you see one? Do you see the 7x squared? So you're going to bring that one down and write it next to its like term. Remember, guys, variables are only like terms if they have the same exact power. Okay? So I'm going to match my x squareds together. Now I'm going to match my next power of x down, which would just be x. I'm going to bring down my negative x. Are there any other terms that only have an x? Do you see it? The other negative x at the end. All right. Am I missing any terms from the original problem? Yes, what? -2. Okay, so now I have written this in descending order, and I am ready to combine my like terms. So I see x plus 7x squared. Wait a second, though. The x doesn't have a number in front of it. What number is in front of it automatically? Automatic 1. So what is 1x squared plus 7x squared? 8x squared. You add the coefficients. That's what we said here. Add the coefficients of the like terms, and then we bring down the common term. What is -x minus x? We can put our 1s here to help us. What would be -1x minus 1x? -2x. And then bring down your -2 because there's nothing to combine. You are done. You cannot simplify this anymore. You say, well, I have my x's here. Yeah, you do, but they're not the same power. So they're not like terms. You're done. All right, questions, guys? Okay, now on my next one, do you see the subtraction sign between the terms? Okay, so I have a rule here. And essentially what's happening is this subtraction sign is going to get distributed among all the terms. So here's what it looks like. You always, guys, have to rewrite these. When you see a subtraction sign, you're going to just rewrite the first one because it does not have a negative in front of it. But now the negative becomes a positive. That's what my rule says. Okay? Change that subtraction sign to a plus sign. Then my rule says I change every term inside the parentheses to the opposite sign. All right? So it was -4p squared. What would it be now? Positive 4p squared. It was -p. Now it's going to be what? Positive p. It was +3. Now it will be -3. Now you're ready to group your like terms together. Okay? So when you see that negative, you're about to have one that you're doing on your own. You must change the signs before you combine. All right? What is the highest degree or the highest exponent value that you see here? What's the highest value? P squared. So write p squared. Are there any other p squareds that I can match with that one? All right. Would it be plus 4p squared or minus? Plus, because that's the sign I see in front of it. Plus 4p squared. All right. Now I'm going to go down to a p. Do I see any p's? Do I see any p's? All right. Minus p. I'm sorry, I messed that up. It should have been plus p. Look, I messed that up. It should have been a plus. So plus p. And then, is there any other p term that I would bring down? Another plus p right here. Okay, bring it down. What about my numbers? Plus 3, minus 3. I bring down the -3. Okay? Now, this is not my final answer because I must now combine my like terms. All right, I'm going to give you about 20, 30 seconds to go ahead and get to your answer. All right, can anybody raise your hand and tell me the answer you got? Kaylee. Plus 2p plus 0, so you don't even have to write the 0. All right, 3 minus 3 is 0, so they cancel out. 5p squared because there was an understood 1, and 1 plus 4 is 5. All right, great job. All right, so we're going to pause here for about 3-ish minutes, okay? And I want you to simplify these two expressions on your own. I'm walking around, checking on you guys. You can check your answers with each other. Once you have an answer, you can double check. All right, so we're just going to take a couple minutes here to work these problems on our own. All right, so a couple things we need to clear up. When we see the negative, did you guys notice the subtraction sign between them? That means that we keep the first expression the same. That negative does change to a positive, but the first expression stays the same. I do not change that one. I only change the expression after the negative. All right, so do you see I made 3k squared negative and I made negative 6 positive. The signs after the subtraction sign are the ones that change. Okay, now I can match up and write this in standard form. What is the highest exponent value I see here? What's the highest exponent value, guys?
3k.
Negative 3k squared. Okay, what's the next exponent value? Minus k. Minus k. Then my numbers always come last. So negative 3k squared minus k. Can I combine them together?
No.
I cannot, because they don't have the same exponent. They do have the same variable, but they also have to have the same exponent to combine them. So I leave them separate. Plus 11. All right? Did you get it right? If not, do you see what you did wrong? All right? Are we correcting what we did wrong? The next one to me was a little easier. Okay? Match up my B's. Don't forget what comes out here in front of the first B. The 1. Okay? Minus 10 minus 3. So 1B plus 4B is 5B minus 13. All right, you have big ideas homework tonight, so I want to at least get started on the first couple questions if there's any time left in class. And there is, at least for y'all. And that's everything you need to know for lesson 1.